Okay. Yeah, I'd like to welcome people to tonight's webinar. It's great to see people from all over the country attending. Got a fantastic kind of distribution of people. And we've got, yeah, nearly 100 people booked on. So it's going to be a really busy one. Thank you for joining us. This evening's webinar is about window installations for energy efficient retrofit. And we've got Bill Butcher and Chris Herring from the Green Building Store, who have an amazing amount of expertise in this area. And there's myself, Jonathan,
Awesome.
a lot of years expertise. We've got also myself, Jonathan from Carbon Corp, and we have Liam, who's also Carbon Corp. He's a retrofit coordinator. Hiya. A few things, a few bit of housekeeping before we start. The slides and the video from this evening will all be made available. You can see a link at the bottom of the screen there, at carbon.coop webinar program. So they'll go up there probably tonight or tomorrow morning. So if there's anything you missed, you want to go back, go there. Say hello in the chat. And do interact as we go on, and converse and talk to each other. What I would say is we're not going to save the chat and share it. Often people say, can we see the chat? Just because of things like data protection and privacy, people might be sharing things, there are names there. So if there is something you want to see in the chat, do grab it. You can cut and paste it yourself or copy it. If you have questions, please use the Q&A. So it's in the toolbar at the bottom of your Zoom toolbar. There's a Q&A. Just use that for questions. Don't chat in the Q&A. Don't pose questions for the presenters in the chat. So what we're going to do is going to do a presentation. I believe Bill and Chris are going to do a double hander. They're both going to do it together, and then we'll have time for Q&A from you guys. Should be about 7 till 7:30, but let's see how we get on. Bill has said he does want to be interrupted with questions, and Liam will be monitoring them and interjecting if needed. And just to remind people, we can't advise tonight on your specific home or project because we've never seen that home and because there's a limit to what we can do via the internet. But we'll talk about general approaches and things to bear in mind and signposting all sorts of stuff. If you're interested in any of our webinars, please check out the website, the Carbon Corp website, and we've got the YouTube site as well that's got all the videos documented. Yeah, okay. What I'm going to do is hand over to Bill. And yeah, I'll stop sharing. Are you able to share your screen?
Yes, thank you, Jonathan.
While you're just finding the technology, Bill, just to say we're doing this as a double hander tonight, aren't we? And
yeah.
So Bill will be doing the bulk of the talking, I think, looking at detailing, but we're doing some basic sort of theory as well, which I'm just going to run through, and then we'll take our questions between us. And we're happy to take questions as we go, although we probably can't read the questions and answers, so we may not, if we miss it, don't worry, we'll come back later. And I know Jonathan.
I think Liam comes in with the questions,
yes.
Chris.
Liam's going to jump in, right?
Yeah,
that's fine. Yeah,
I don't think we need to worry about that. Anyway, hello everybody. Thank you for coming along. This is the new world, isn't it? COVID, and how strange it is 1 year on, and we're still here. Anyway, Chris and I are old folk, I suppose.
Just talk for yourself.
We started Green Building Store in 1995, I think it was.
Yeah.
Mainly to supply green building products, I suppose, to put it very crudely. And one of the first things Chris sort of brought up was that there were no green windows at the time, if you like. Both in terms of low toxicity, because it was a time of, dare I say, rent-a-kill and all the horrible wood preservatives, paint systems, and also good glazing systems with sustainable timber, which didn't which at the time were rotting. So we sort of farmed it out, Chris, didn't we, to others back in.
We started in a garage and a shed, didn't we?
We did, indeed. Yeah, we're not much better off now.
It was actually toxicity that started us off, because I and our third partner he had both been ill with E type illnesses in the late 80s, chronic fatigue syndrome, and we did a lot of research on wood preservatives as an exposure to wood preservatives, which we'd been quite heavily exposed to during running small building companies. So that's what we asked the question. We want high performance windows, and we don't want PVC windows because of the issues around PVC. We want timber windows, but we don't want, at the time, the very toxic chemicals that we use, things that are now red listed. So we looked for alternatives, and that's how we started. We started with windows, and of course now we've got a much wider portfolio of products, and the business has morphed quite a lot over the last 25 years, I suppose, hasn't it? Anyway, but we better get on and talk about windows, haven't we?
Yeah, but we've still got a building department, which is where we come out of. That's our DNA, where we push the boundaries. Yeah, we use the products and hopefully can give good advice from practical experience. Anyway, let's get on with this presentation. Here actually is a photograph of just a few months ago, of us using a product called diathanite, internal wall insulation. This is a cork and lime system, which is an insulator with a 0.037 lambda value, which is pretty good actually. It's capillary and vapor open, and it's airtight. It just does everything at once. And we've used this several times on some of our very hard to treat barn conversions and farmhouse renovations up here on top of the Pennines. Right, that's my first trip up. Why didn't that work? Yeah. So what are we going to talk about? Thermal bridging around windows. How do we fit windows into openings? The actual window styles in terms of thermal performance. We're not going to go into the aesthetics architecturally, I might add. Obviously air tightness, and then later we'll consider retrofit timing, when windows should be replaced, can it be done in conjunction with other measures, in other words, the whole house plan, and then we'll look at a few case studies, both for IWI, we'll keep on referring to this, internal wall insulation strategies, and external wall insulation. So internal wall insulation, external wall insulation, where we position windows in that case. So thermal bridging. So obviously windows and doors constitute a substantial break in the insulation layer or the building fabric, even if you haven't got any insulation yet. Moving forward, all walls will have to be insulated moving forward, unless you're in some sort of historic building, I would suggest. And we talk about U values, that will come up a lot. So a very good triple glazed window at a 0.8 U value is still going to be 3-4 times worse than the wall that's insulated next to it at about 0.3 for internal wall insulation, for example. We're talking about retrofit. New build, we're right down at 0.15 U value, or should be. So you can see that windows and doors actually are a big heat loss potentially. So we also look at the general principle of design of windows and doors, and it's to maintain the continuity of insulation as far as possible. So obviously we'll talk about triple glazing against double glazing a bit, maybe, well, Chris will anyway. But triple glazing, we're talking about down to 0.9, 0.8 U values, whole window values, that is, not center pane, as opposed to building regs, which is 1.4 at the moment. And from our point of view, in the way the windows we make, there was only 10% difference between the two in cost. And so for that drop in insulation value, we felt it was no point in doing double glazing anymore, actually. So we then got to talk about, ideally this means windows and doors are within the insulation layer and how we're going to do that. And then the structural issues around how the windows are actually held in place. Triple glazing is 44 kilograms per meter squared. It starts to get very heavy and actually has health and safety issues. You can imagine a big full height glazed panel on the first floor up a scaffold in February with snow. It's not fun, actually. So anyway.
Oh, we're increasingly using robots, aren't we, now to do this? Yeah.
And often the bigger windows have to have 6 mil glass, which of course puts it up to 60 kilograms per meter squared. Yeah. So you could be up at half a ton for a big window. On a muddy site, that is, quite some feat. Anyway, so Chris is going to take over now and talk technical.
I think that's probably putting it a bit. Anyway, oh, sorry, there's somebody knocking at my door. Can you just do this one, Bill? I'm very sorry.
Right, okay.
Your neighbour. I'll come back in a moment.
So look, building regs are fairly crude compared to passive house methodology. So, for example, building regs sees the window on the left and the window on the right as the same thing. Yeah. It'll have similar glass, but actually the difference is all that framing in the one on the left. And this is the case for whatever material the window is made of. We're generally talking about timber, of course. Anyway, there you are, Chris.
Okay, sorry, it was a neighbour knocking. This is COVID life, isn't it? Living. Well, in my case, working in a shed, in the garden. A nice shed, but
nice shed. Yeah.
The point about this really is that under the building regulations, we treat a window as a window, basically. So whatever its configuration, it's just got a standard U value. Whereas actually, this is much more complicated. So we just wanted to take a look at this and sort of give you an idea really about getting best value. And I think probably move on to the next slide if I remember rightly. So we're going to take a look at this and see the difference. Okay. So if we just model these windows, actually model these windows and see what the real U value is when it's installed. And we can see the one on the right it's a nice triple glazed window. It's well installed. It's got an overall installed U value of 0.85. Whereas the left-hand window is ostensibly the same window. It's triple glazed. It's the same quality of frame, but because of all those extra mullions and transoms and glazing bars, we've got an installed value, and it's well installed, 1.25. So we could in effect almost put in a double glazed window, and we've put in a triple glazed window. So we've kind of wasted some of our resources by making an over complex window. So really the lesson here is, can we simplify our windows? Can we simplify the design? We're losing light as well, and we're losing solar gain. So we're losing some of the free energy from the sun that we'd get with that larger expansive glass. Can you move on, Bill? Yeah, you see we've got the technology here. So we're just going to step back and look at, many of you may be very familiar with this. So if you are, I'm sorry, but it just gives us a little bit of a sort of building blocks. So we can sort of look at the heat loss through a window in a number of components, if you like. So we've got heat loss through the glazing, and that's given as a U value. As you know, all heat loss is given as U values, which is a heat loss, the amount of heat loss per square meter per delta T, or difference in temperature between inside and outside, if you like. So it gives a measure of heat loss. We've got the U value of the glazing there. That's often called the center pane U value. we've got here we are, Bill's got all the props. We've got the U value of the frame, so heat loss through the frame, which is given as the U value of the frame. Then we will have some heat loss attributable to the edge of the glazing where it sits in the frame. Don't forget the glass is sandwiched together. My able assistant there is pointing that out. In the past, we used to try and make insulated units by using one of the most conducting materials we know, which is aluminium spacers, which is kind of slightly insane. But nowadays, most spacers are insulating spacers. They're sort of thermoplastics of some sort, slightly different, various types. So we can bring that heat loss down, but nevertheless, it's not. It's still significant. It still matters. And that's given by what's called the psi value. And that's a linear value. So that's the heat loss per linear meter of the perimeter of the glass, where it sits in the frame. And if we take, please, Bill, if we add those together, so the heat loss through the glazing, the edge loss, and the frame, that's given as the U value of the window. And that's what will be quoted for building regulations. So we've got a window with this U value. If you go to a show and look at a window, you'll normally see the U value quoted is that. We have also got some heat loss, though, from the installation. And that's called the psi value of the installation, or psi W, psi value of the window. And this is the heat loss at the edge. It's not to do with air movement or anything like air leakage. It's actually, if you take the heat loss through the wall, the heat loss through the window, there's a little bit of heat loss attributable normally to that junction. And that's the psi value of the window, or the psi value of the installation. And we can give a total overall heat loss, or U value, for the installed window, which includes that. Now, the interesting thing here is that is not included in our standard methodology. It's BSEN 10077 parts 1 and parts 2, which we use to model the performance of windows. It will presumably move back to a UK standard eventually, but it's a BSEN at the moment. Thinking about that changes the way we look at windows, because the problem with UK methodology is that heat loss is normally attributed to the wall, and it's done in a slightly crude way. It's put into a Y value most of the time, or can be put in as a psi value, but it's into the wall value, so that you don't actually notice it. But if we actually take that installed U value, it starts to inform our practice and make us really think about how we install our windows, so we don't waste the good value of the window we're putting in place. So we can move on to the next slide, Bill. And this is where the science comes in. Not really, it's just formulas, but just keep whack through a bit. That's right. So the heat loss through is calculated to BSEN 10077 by adding up the heat loss through the glass, the heat loss through the edge loss of the glass, and the frame value, and dividing that by the area of the window. And that gives us a U value, and that's the formula, but that's what we're doing. Very simple. Now, if we calculate the installed window thermal performance, it's exactly the same, but we're going to add on the psi value, or the heat loss attributable to that installation. And if this doesn't quite make sense, it will do in a minute when I illustrate it. So we're adding on, we've got along the same formula, but we're adding in the installed heat loss in effect as well. And that gives us a much better discipline for thinking about how we install our windows. And it's something that we've come to take into account all the time through the Passive House methodology, because Passive House makes you take this into account. It makes you model a building properly. We sort of did quite a lot of pioneering work on Passive House, and we still use the methodology all the time, and the Passive House planning package. So it really drives you to think about this, and then you are driven to think about the way you install the windows, which is what we really want to talk about tonight. So I think if we can move on to the next slide, if I remember. Oh, we're slightly jumping here, but we'll come back to, that's okay, we'll come back to the thermal bridges in a minute. But a point to make here is that every building, in fact, has an energy balance. This happens to be a passive house. So if you take the two left-hand columns, you've got the heat gains and the heat losses. And if they're in balance, which they should normally be if you're in your house, you're balancing any heat gain or any heat losses through the fabric, through the walls, through the ventilation, by the heat from your body, from your how you live, and of course also your heating system and any free heat that's coming from the sun. And those two will be in balance, otherwise the building is either getting warmer or getting colder. So there's an energy balance there. Now, this energy balance is actually for a passive, it's for the first ever passive house actually. And so you can see that there's not very much heat loss from ventilation, and most of it's in the fabric, and even then it's very small. But the point here is, look, if we then take that fabric heat loss and you look across, you'll see that windows actually account for about 50% of that heat loss. And this is in a passive house with triple glazed windows, the very best windows and the very best fabric. But the windows will still account for a huge chunk of the total heat loss. And that's because, as Bill said at the beginning, the windows might have a U value of around 0.8, whereas the fabric might be 0.1. Or if you're looking at a new build in the UK at the moment, in theory, you might have, so let's say a retrofit, for instance, we might be putting in double glazing, something like 1.4 U value, and then the walls at 0.35. So again, you've got a huge difference. So although the windows, in this case, are taking up 12% of the area, of the surface area of the fabric, they actually make up 50% of the heat loss. So they're incredibly important to think about, and getting the best value and getting best performance from your windows really matters. There is another part to this, which is of course that windows give us free solar gain as well, but we haven't really got time to cover that tonight, but there is a balance in it, if you like. So can we move on, Bill? Yeah, this is just showing the balance. This is a little diagram from some years ago, actually, and he's looking at double glazed windows, although we're really normally looking at triple glaze. It was some work done by Professor Bob Lowe when he was with his team at the Centre for the Built Environment at Leeds Beckett University, then Leeds Metropolitan University, and it was a Red Row project, wasn't it? I think Stanford.
Yeah,
Brook.
it was.
And they did modelling. Red Row were building to well beyond building regulations at the time. It's about 20 years ago. And they looked at where to position windows in the wall. And this is a cavity wall construction. And so we created a little graph just to illustrate that. And you can see the difference. If we put the window in the outer leaf, I think, if I remember, that's the way around. Next, click.
Sorry.
Yeah. So if we stick the window in the outer leaf, which is not uncommon to put it somewhere in the outer leaf or near the outer leaf, you can see we've got a significant psi value there. And the installed U value of the window would be 2. This was a double glazed window. Whereas if we bring that window into the insulation there, our psi values drop right down, and our overall installed U value for the windows dropped to 1.5, which is only just a fraction over the double glazed window at 1.4. And then if we move further into the insulation, it doesn't make much difference. But then, of course, if we put the window in the inner leaf, which is probably not, I've never seen that done, but again, your psi value goes right up again, and you go back to an installed value too. And this is another way of illustrating it. So here we've got, this is actually a typical German detail, but we'll look at a more typical English detail.
This could be a solid wall situation in this country.
It could be actually as well, couldn't it? Yeah, with external insulation.
Yeah.
And here we've got the window sitting in the masonry, so it's been replaced. So we've externally insulated, but we just replaced the window where it was before. We've put in a nice triple glazed window, the U value of 0.8, so good, nice quality window there. And we've got a psi value there, a very high psi value, 0.26. Don't worry about the numbers, but you'll see the effect in a moment if Bill can do his clicking. So if you look at that, it's pretty obvious that there's a huge thermal bypass, because you've got the heat can just transfer around the edge of the frame through the masonry. And of course, you've got 2 problems there. One, you've got a lot of heat loss, and 2, you've got a very, very cold surface in that reveal coming in from the window. So you're almost certainly, you've got a lovely insulated wall, which is warm, and then you've got this incredibly cold surface. And so you're going to get a lot
where you'll get condensation
and mold growth. And if you haven't got black mold on there within 6 months to a year, you obviously be very surprised. But look at what happens to the window. So the installed value of that window, our window was sold as a 0.8 U value window, a nice triple glazed window. But with that awful psi value, our installed value is 2. So it's worse than a double glazed window. It's quite a poor double glazed window, in fact, equivalent. So just the impact of installing in that position, and that, you know, that's not uncommon. You can see that done quite regularly. The effect of that thermal bridge there is enormous. And yet, if we hadn't modeled it as an installed side value, an installed window value, we wouldn't have noticed it. We wouldn't really have got that impact until our walls started going moldy. So if we move the window out into the insulation like this, and even better, try and bring that insulation around the frame a little bit, and this is Bill will be looking at the details of how we do this later, suddenly we get a lot better value. So Bill, there we've got our side value is 0, so there's no extra heat loss. So our installed value is 0.8. So we've gone from taking a 0.8 window and, you know, losing a lot of that value because so much heat loss around the window, to just by repositioning it in a better position, getting really optimizing the performance of the window. And this is the real lesson here. And this is the bit that Bill's going to be picking up in terms of the detailing.
Could I just say that this is the case with internal wall insulation as well as external. We're just showing external at the moment.
Yeah.
But internally, it's just the same.
Yeah, and you're going to look at that detail.
Yeah.
I think there's a couple more slides for me. So let's go back to this now. If you remember, we had a nice 0.85 U value installed for that simple window on the right-hand side. And if you remember, it was 1.25 well installed with that extra detailing. Then if we install it badly and we get a really bad side value, which would not be untypical in this country, suddenly that window goes to a 1.8 installed U value. And that's incredibly wasteful. You know, we've just spent quite a lot of money on a nice window and we've installed it badly and lost all that gain. So my partner's coming behind me with her bike, so there's a little bit of movement behind us. So, which was the next slide, Bill? Because I can't remember. Oh yeah, and one more example here. This is a schematic. We built one of the first passive houses in the UK, a cavity wall construction, and it's a schematic. It's slightly simplified, but we installed the window in the centre of the insulation in the cavity wall, and we actually ended up with a negative side value, which takes a little bit of thinking about. So I installed U value for the window actually goes down. So click, Bill. Yeah. So our installed U value, that was a nice 0.8 window. It's actually slightly below, but keeping numbers simple here. We ended up with a 0.75 installed U value for that window, for that typical size window. So it can make a huge difference. And again, this is just, as I was saying earlier, you know, passive house has been very important to us because the methodology has really driven us to do things properly. And this is just an example. It's actually, it's an earlier version of passive house planning package because I'm not up to speed with the new version, but the principle's the same. What you do is you put all the details of the window in. So you don't just take a nominal U value and say that's it. You actually calculate for each window exactly how that window is going to perform. And click a little bit more, Bill. And again, and there we are. It brings up. So each window, it's calculating the actual U value of the window, and you can see depending on the size and exact configuration, they'll be different. So that's proper calculation, and it will calculate the installed value as well, because you're putting in the installation side values, which we have to model. Not necessarily saying that we need to do that certainly with all retrofit, but the important thing is that we need to understand these implications and really think about where that window goes in the wall and how it's installed. And I think you, Bill.
I just wanted to jump in. We've got a few interesting questions coming up.
Yeah.
I didn't want to interrupt earlier because I was quite enjoying your man named Chris. Lots of figures asking for the next slide, please. So yeah, we've got Guy McNaughton. He's asking the example shown for solid wall has external insulation. So what position would you use for a solid wall with internal insulation?
Well,
I'll talk about that in a minute. Yeah.
All right. I was a bit concerned some of these might be spoilers. So. Okay, there was also something about sash window refurbishment with slim double glazing and secondary glazing compared to a new double glazed window, and what sort of performance difference you might have?
Yeah, I can see.
That's mainly to do with air tightness, to be quite honest. Sash windows are extremely difficult to get airtight, and it's more to do with air movement and drafts than it is with the actual U value.
Yeah, the question's also looking at secondary glazing though. So your secondary glazing can be giving you your air tightness. It's quite difficult to say. I mean, if you've got sort of conservation area and you're really stuck with your sash windows, then probably, yes, secondary glazing with a double glazed window, probably on the inside, or even a triple glazed window, depending, could make sense. It's quite hard to be specific. Slim double glazing, unless it's very high tech, probably doesn't give you much performance. So so if you've got a very narrow cavity with conventional double glazing, the performance drops off quite dramatically. You can make a difference by putting krypton gas in the cavity, but again, the price goes up a lot. That's, I don't know, used to add £100 square meter. We don't do it anymore. So, or you can even put vacuum glazing in, but again, that's more expensive again. So if you can replace the window with a good triple glaze, you're probably going to get the best performance. If you can't, for conservation reasons, then secondary glazing. But I'd leave single glaze on the outside, really. You might end up.
Chris, we can do sliding triple glazed sashes. We can do.
Yeah, we can.
They're expensive.
They are very expensive. Yeah. So I think it's very much about looking at the individual circumstance and sort of guiding you through what your best option is, really, I think.
Okay, cheers. There was one more quick question about changing from old poor performing double glazed to insulated timber frame to triple glazing. Can that significantly change the moisture content of the internal atmosphere in a room?
No, it doesn't have any effect on the moisture content of the room at all. Well, except that obviously a cold surface will collect moisture because you're hitting viewpoints, so you've got a lot of condensation on the window, I suppose, taking some moisture out of the room, but fundamentally it doesn't. You want ventilation, is what affects the moisture content of the room. It does affect whether you get condensation though, because obviously if you've got a cold surface, as I say, you're hitting viewpoint on the window and you'll get condensation. And if you've got high humidity, you almost certainly will get, depending on, well, poor performing double glazing, you'll get a lot of condensation. And it's one of the, interestingly, with Passive House, obviously the methodology is designed to make the building very comfortable and work beautifully. There is a guarantee of no condensation because the calculations are done to ensure that. So again, well, yeah, and the only thing to say there is normally in our climate, I wouldn't normally recommend insulated frames. I'd recommend solid frames, but triple glazing will give you all the benefits of no condensation.
Cool.
Okay.
Keep going?
Yeah, keep going. Yeah. Right. Okay.
Isn't it?
So, right. Carrying on from what Chris has just been talking about in terms of positioning windows, this is typical of an external wall insulation retrofit, radical retrofit, the drawing. This suits an inward opening window. So you can see that the bulk of the frame is sat on the outside externally here. Yep. Which means that we can wrap the frame, in this case with XPS or EPS, this sort of material. Yep. Or wood fiber, or these sort of external wall insulation systems with renders on. That's a semi-rigid mineral wall, or of course, favourite of the carbon co-op, wood fibre board. Okay, so this improves that psi value that Chris is on about greatly. Sorry, here. Now, what's interesting with this drawing is that they're doing it on a cavity wall construction. We wonder sometimes whether we can get a good enough thermal performance with I mean, we're showing it here on drawing as a fully filled cavity. That's easier said than done in an existing cavity wall, filled, with mortar droppings in there. Bricklayers can never keep a 2-inch cavity clean, and that's impossible. So if we've got air movement in this position or behind the insulation, very important to stop what we call thermal bypass, because that can diminish the performance of all of this here. Anyway, this is a nice, neat example of an inward opening window with external wall, with quite often, usually we use these sort of aluminium extension sills. These are sort of standard European models, if you like, with usually with one of these end caps, either with sorry, holding it the wrong way, either with one for render to render down to, then got a drip, or if you're flat against brickwork or so forth, that can be there we are. So that gives protection to stop people gouging themselves as they walk past. Internal wall insulation is the opposite look. So the outward opening windows perform best. So we've got the bulk of the frame here on the inside. So that will be able to take insulation in a better way. Here's an example. This is our friend Paul. Oh goodness me! Come on, Chris. Paul Sheffield. Go on, our good friend Paul.
Paul Tester.
Anyway,
Paul Tester.
Paul Tester. Yeah, this is his own.
I'll be the question.
Wood fiberboard. I do question actually what all these holes are about here. I hope they're all taped up and everything later. But anyway, this is the principle. This is one of our projects with that diathanite I showed you earlier being sprayed on, again with outward opening windows. So that means that we can actually, in this case, take the 4-inch, or sorry, 100 mil. We've got Brexit now, haven't we? So we're supposed to say inches, round the corner back into the frame. So that maintains our U value into the window. I hope that answers one of the questions that Liam came up with just now. So what about air tightness? We need that continuity, obviously, both in insulation, but in air tightness. What we tend to do, what we teach in Passive House, is that you should be able to take a section of any of your a slice through your building, and be able to, on paper that is, and be able to draw a red line, and it's always red because it's on the warm side, all the way around your building, ideally, without taking a pen off the paper. And that will include maybe concrete, may include wet plaster, may include renders, plywood, OSB, tapes, membrane, whatever. What we want is one continuous line. And you've heard this many times, I'm sure. One leaky bucket inside another leaky bucket is a leaky bucket. So the window is part of that red line, if you like. So we need to tape into it, and we need to have good seals, and also the glazing put in properly as well. I mean, we've been called back, Chris, haven't we, in the past, the glazing not being functioning properly, actually.
Well, almost anything that can go wrong does go wrong at some point.
We found out about
lessons I learned in life. So, yeah, yeah, and we've put it right, of course.
Yeah, and we continue to find out about trouble as well. But anyway,
learn more and more things that can go wrong at some point, however
yes. Anyway, so windows and doors obviously comprise that air tightness of the building by creating a gap in the building fabric. So this one, Chris, talk what us.
Oh, right, yeah.
Through this one.
I mean, very simply, really, there are different classes of air tightness. So when you are looking at windows, you do. I mean, a good window should have a class 4 air tightness. So this is it's a BSEN again, BSEN 12207, and there are classes 1 to 4. They're tested. It's not mandatory to test windows in this country. It is in many countries, under the CE marking. since January 1st, obviously the world has changed, but up till then we were subject to CE marking, and we're in a transitional arrangement whereby CE marking is still accepted until the end of the year. So all construction products, listed construction products with that are subject to a harmonized European standard should be CE marked, and that includes windows. Obviously it's all changing this year, and by next year we shall have a wonderful UK equivalent to the CE mark that every window supplier will have to have moved over to.
No, we'll see about that, Chris.
I'm not trying to get you chuntering about Brexit, Bill. But anyway, at the moment, so different European countries apply the CE marking differently. So it's not mandatory to test to EN 12207, but all good window suppliers will have done so, and really should be looking at a class 4 air tightness, which is the sort of air tightness you want for, certainly for passive house and for a deep retrofit. So just look for that, basically. One other thing to talk about is seals. I mean, one of the nice things about windows is to reduce the sight lines of a window, because they look a little bit more elegant, and also you get more glass in relation to the frame, which means a little bit more daylight and a bit more sun coming in. So you improve your solar gain. So you'll find, I mean, I'm illustrating timber windows here, but and PVC windows often have quite fat profiles anyway. But you find that certainly often a second seal is sacrificed in order to get a slimmer sight line. We don't think that's a good idea. We think 2 seals is much better. And even if that's a slight compromise in the width of the frame, that's sensible to get those 2 seals. The reason is because seals in the end can be vulnerable, and if one gets snagged, you lose your air tightness. If you've got 2, you've got a much more robust and a long-lived air tightness. Obviously, seals can be replaced, but often people don't, so they're living with poorer levels of air tightness. You can mitigate slightly fatter frames by the way you detail them. If they're an outward opening window, you can sort of bring reveals in, or you're probably bringing insulation in, and you lose some of that effect of the slightly fatter frame and to give you a more elegant look. So there are ways around it as well. So we would always advocate 2 seals. Obviously, if you can reduce the frame height and have 2 seals, that's great, but there's a limit to that because of the simple geometry of the frame. I think back over to you, Bill.
Right, so air tightness. Crikey, we've only got a quarter of an hour left.
Yeah, well, we're mixing questions as well, aren't we? So
yeah. So yeah, we've got time. So obviously we're trying to minimize the air penetration. So we would recommend proprietary air tightness tapes. These on the for that red line. Remember I talked about that continuous red line on the drawing. Now with external wall insulation, one could have an air tightness strategy on the outside of your wall. Yeah, so you would actually be taping to the outside. That air tightness strategy might be with EWI, it might be the renders, or it might be actually the adhesive, or a vapor or a membrane actually. With internal wall insulation, you will want to be taping internally. Obviously, for weather sealing, there are several different ways of achieving that. Traditionally, silicon, or we often use burnt sand mastic round here in West Yorkshire because of the stone, which is fairly it can be all over the place basically. So rather than have great lumps of silicon everywhere, we tend to try and use this burnt sand mastic. We are tending to use this expanding tape, and I've got a roll somewhere. I can't see it at the moment. Compriband is one of the trade names for it. There's Vitaseal and there's several others. We do ones called Fitten, and that actually expands at least 3 or 4 times its actual width that you get it on the reel, and that expands into the gap. That can be extremely neat actually. So this tape we use an awful lot. It's called, obviously, as it said there, Contiga. And this has got a fleecy finish to it. And this can be used just as an air tightness onto plywoods or membranes or whatever, but it also takes wet plasters and renders, and that is the air tightness strategy in its own right. So all these tapes have a acrylic glue system, which is extremely they're extremely good, actually. We're lucky that they've been developed abroad, namely in Germany in this case, and have got accelerating life expectancy of well over 100 years now, actually. And they're very good, these tapes. They do work. In fact, if you get them on wrongly, you'll never get them off again. So one has to be a bit careful, as I'm going to say in a minute. So there is another version of it here called SLD, which has a third adhesive strip on the other side here. So what we're showing here is Andy pre-taping a window before installation in a plywood box. And look how careful we have to be. That there is called a rabbit's ear, and that pinch actually takes up the slack you have between the size of the window and its opening. We always allow a 10 mil, or usually a 10 mil tolerance, all structural opening, even in new builds, and never going to be exactly square. Okay, so what will happen there with Andy, we'll put these straps on the side, screwed into the side of the window, and then be screwed into the reveal. Here we've got a plywood box. We use plywood boxes to hold windows out beyond the wall or in the middle of the insulation, just as the way Chris was showing. And our air tightness strategy would be this window, that tape onto the plywood, and then our Contiga tape again onto the blockwork, then wet plaster onto that Contiga tape. So that's our red line. I hope that makes sense. So that's pre-taping. So post-taping is when you obviously have installed the window, just as I've said. And if you can imagine that half a ton of window I talked about earlier in February up a scaffold in the snow, you cannot really guarantee that that pre-taping is going to stay on there as you're trying to get it in. So quite often we'll use either method. So they're both as good as each other, but the pre-taping is actually quicker. So the post-taping, we use this material called Profil, and it has two tear-off strips. Look, can you see? So we've got a 10 mil and a 50 mil here. So the 10 mil goes against the frame here. Yep. And the 50 mil against the reveal, obviously, but don't take it right round the corner. Cut this tape in 4 sections, and then what we do is make up a little pocket. Look here, can you see that? Which we stick into the corner. This 10 mil will then be able to be covered by plasterboard for a good finish. We have to really make sure that this tape doesn't go over that line that's going to be covered up by the reveal, either plywoods or plasterboard and skim, for example, because this tape fuses into our pre-finished window and you can't get it off again. And there has been some tragic cases where we've had to replace windows where it's been done badly. This tape is great for repairing jeans, saddlebags, back of books and motorbikes, by the way. It is quite expensive, so one has to use it very sparingly, and it comes down to design. So it has to be buildable, else you'll be all over the place using lots of tape, not very effectively. So, and it has to be dry and relatively dust-free. So this trade, if you like, of taping is a bit, well, some people say like dressmaking. I think it's an attitude of mind. It's not rocket science. It just is that I sort of joke. You need to have done meditation before leaving home, hopefully not argued with the kids, not got a mobile phone on you, listening to Radio 3 all day, and just get on in a very methodical way.
You last do meditation before leaving home, Bill?
Well, I basically must say that I'm the worst at it, by the way.
I must say that I prefer Radio 4 for airtight taping.
Oh, right, well, fair enough. Yeah, but you can get mad then, can't you? Then that's
We've got an Air Tightness champion here.
Yeah, well, that's true, actually. A Radio 4 Air Tightness champion. That's interesting. That's another debate, Liam. Right. Outward opening windows, IWI. Look, this is an example. And what we want this sort of at least thought pattern. If it's going to be a job done by, in the traditional way with architects and all the rest of it, this is the sort of detail that we need, particularly for builders that aren't used to doing building work to this level. So we'll want to specify the tapes. We want to tell them whether it's Contigo or Profil or Tescon or whatever. Okay, these are the sort of details we need to go through, both in new build and retrofit. So here we have an example of outward opening windows in a timber frame. And here we have an example, yes, this is an example of the other way around. So this is outside world and this is inside, and that's actually a horizontal section through a window or door, a door opening. And look what they've done here, interestingly enough, they've got a sloping, what would you call it? A raking reveal to let in more light. That quite often happens with thicker walls. Thresholds, really difficult detail. So remember, we're talking about thermal bridging detail. We've talked about windows and the thermal bridge details. What we have with thresholds is also structural issues. Obviously, people trundling over here. This is an example of, and we use this a lot actually, where we use this material called compact foam. This is a heat-treated, heat-altered polystyrene that has a lambda value, I think of 0.047, something like that. So it's still pretty good, but it's structurally sound. And look, we can use it, saw it, route it, screw into it. So here we use it to bolt into the side of the slab. What we often do is actually cast our compact foam here into the slab. So we'll have a threaded bar set up here, and it almost acts like formwork for the floor to be floated in. And then you can actually put another piece on top, look, when the screed gets done. This is a neat way of getting a thermal performance and a Part M compliant threshold, Part M being the building regs for mobility access. Same with lift and slide door set, same sort of thing. So retrofit project. So key questions. What happens when we've got existing windows, or do we replace? Questions about back again to IWI or EWI, and then the sequencing of retrofit works, because often you can't do it all at once. So if the windows and doors are to be replaced, it is a lot easier to ensure continuity of installation, as they can potentially be repositioned closer to the installation. Remember what Chris was saying earlier. So what we want is a whole house plan, where we're looking at the building moving forwards over the decades, where we, if we're going to be going for external wall insulation, if we're replacing windows before it, do we put the windows out, or do we do it temporarily in the same position, move them later? So also be aware with internal wall insulation, if we move the windows further back in, because a lot of 1960s houses were sort of pretty shoddily built, in my opinion, and 70s, where the windows were actually positioned right close to the outer brickwork, where with wooden subsills, that was the cheapest way of doing it. So what we tend to do is move the windows back in for better performance with IWI. But one of the downfalls of that is the actual painted mastics that are left on the brickwork if you move the windows back in, and that can be quite troublesome in getting off. If existing windows and doors are to be kept, we can reduce thermal bridging with space saving around the window reveals to reduce thermal bridging. Right, what we're saying here is that if we're using internal wall insulation, say 4 inches of or 100 mil of wood fibre board, for example, we want to maintain a U value into the window, but there isn't with existing windows the width of frame to get the same width into the reveal. So we can use expensive materials with a lot better lambda value. That's the thermal performance. This is the first one. It's called Space Blanket or Aerogel. This is actually vapor open, and we use this a lot in retrofit for reveals, particularly with weavers windows around here where we don't want to lose any more light. So the lambda value of this is 0.015 as opposed to Kingspan or PU of 0.22 or wood fibre of 0.38. So you can see that just a thin blanket of this is relatively good performing. And then you can go even further actually and use these, which are called vacuum insulated panels. They're a bit like coffee packs. I'm told it looks like it's silica powder, granules in there. Some people say it looks like cocaine. I wouldn't know what cocaine looks like, of course. But very expensive. Lambda value of these things are right down at 0.007, 3 times better than Kingspan, PU, PIR. Very useful where you don't have much width to get into the back of the windows on reveals. So to ensure continuity of insulation, they must be ideally placed. We talked about that already. So with EWI, we tend to push the windows further out towards the insulation. We ideally at least to the front of your masonry, so that the insulation can cover the frame, as we saw a bit earlier. We can leave them in the same position, but we've then got the detailing of taking insulation round into the frame. Remember that heat loss of badly installed windows. Better still is actually holding the window out in the insulation itself, so the frame is completely wrapped. And we'll show some examples of how that's done in a minute with brackets or plywood boxes. So if using internal IWI, you may be able to place windows further inside so that the windows are deeper and further away from the external wall. But of course, that depends where vertical DPCs are and how your existing external sill is constructed actually. We usually have to put our windows back in the same position with IWI, to be quite honestly. So with retrofit and step-by-step methodology, and by the way, Passive House has an Enefit step-by-step certification route now, where you can actually do the steps, get it certified and pass it on to other owners of the building, recognizing that to rip out a reasonable plastic double glazed system that's been in there for only 5 years is just not sensible. So with our EWI, you could replace the windows and doors and locate them in position flush with the outside with the EWI to wrap it later. But of course, we have to be very careful of weatherproofing then, and actually aesthetics. I don't know how well it would look, to be quite honest. Or could you put them in the original position with straps? Remember these sort of things, to then be let out, to be unscrewed and pushed out when the EWI is done. If you're installing the EWI first, any replacement windows should be would need to be pushed out later for obvious reasons. And don't forget the air tightness strategy. How's that going to work, both in the temporary position and the long-term position? And obviously the sill will alter as well. With IWI, one could, if one is replacing windows later, use almost a temporary box reveal system like we've got here. That's quite neat. This looks like they're going to probably do EWI later, and they'll move this further out. That's quite a neat way of doing it, actually. So if the windows can be removed from the outside, one has got to think about if you are going to replace windows later but have done IWI, internal wall insulation, are you going to be able to get the windows out from the inside, from the outside, for example? All these things you're going to have to think through. So just a few retrofit projects just to look at here, some case studies. This was that Cumberworth job we talked about earlier with the VIPS panels, the vacuum insulated panels. These were actually the EcoPlus windows that we built here in Huddersfield from about 10 years ago, triple glazed, 0.9 U value. But we only could manage to get 10 mil of insulation in there. The windows were particularly not big on this particular existing barn conversion. And we certainly didn't want to lose any more light or replace the windows. But of course, with the lambda value of 0.007, it was as good as the 100 mil of Tech 10 we used per light on this wall here, actually. This is an example with where we're bringing that diathanite. And what we've done here, this is far more radical. And when you see a barn or a house that needs totally wrecking, you rub your hands and say, great, that's going to be economic to do. We actually made the internal aperture bigger than the external so that we could get the same 100 mil of diathanite round into the window frame, outward opening windows. And here we are. This is where we can maintain that same thickness, a 4-inch into the back of the window and door frames. This is back to Paul Tester's job. Look, we've seen this earlier. All the same principles going into outward opening windows, look, with the thicker bit of frame here. And here we are with another job by Paul, where, look, the windows, I think, in the existing house have been brought out to the face of the wall here, ready for external wall insulation. So and that looks like they're the outward opening windows, actually. So that must have IWI in that part of the build. This is external wall insulation with inward opening windows. Wood fibre systems here. This is one for our dear friend Gil Shalom down in Nottinghamshire. Again, this is probably...
I think Gil might be on the call, actually.
Is he? That'd be nice.
I thought I saw that.
Right. So, yeah, here we are. Look, perfect detailing, Gil. I assume, well, I don't know what sort of system this was, but look, we've covered the frame as good as we can get. No transoms, all glass. That's as good as we could do, actually. Here we are again. Oh, this is Gil's job as well. In fact, I'd asked him, how did he get air tightness in the cavity here? Easier said than done, I would suggest. Right, Now, to get the windows to perform even better, look, these are inward opening windows again. We could bring them out into the insulation. And this methodology is using plywood. There's a box section to bring them out. And here again, look, and it looks like the air tightness strategy is on the outside underneath the insulation. This is where our red line is here. So we'll be taping from the face of the window round onto that masonry here. We can also use, obviously, the compact foam system. So a lot of windows are hung out with a batten of this, at least underneath, to hold it out, or all the way around. Sometimes we'll use some of this on the bottom of windows, screwed into the front of masonry for EWI, and then some metal brackets on the jambs and maybe the head. That makes sense. Here we are again. Look, this is pulling out the windows and doors on ply reveals here. Okay, and this is the yes, here we are, look. So this is an existing bungalow. There was our existing sill. I'm not sure whether they've actually snapped that sill off so that it's made flush with the rest of the wall. Probably have actually. So they'll then put the external wall insulation over the inward opening frame with probably the aluminium. Yes, they are the aluminium sills covering the EWI. Here's a nice example by Sarah, our friend Sarah Darwin from Stockport. This is a job for Mike and Carol, I think it is, in Almondbury, isn't it? Where this is a quite famous house by Arthur Cornby. So she wanted to maintain its architectural integrity. So we look at the detailing, it's lovely detailing here of cutting out thermal bridging and so forth. And then we'll just do a bit of selling now, I think. Chris, you can be a salesperson and talk about the windows we do.
No, well, as Mike, our sales manager, knows, I'm an appalling salesperson, so don't worry at all. We just Mike makes us put in a little bit of information about our products at the end. So and I know some of the carbon cart people have our performance window. This one, so we've got 3 ranges of windows, and our performance and ultra are our 2 main ranges, if you like. This is performance. They're all triple glazed. The performance is slightly less deep than the ultra range. They've all got secure by design. They're all FSC certified, and they're available inward and outward opening. So this is performance, and there's a picture. You can't really tell anything from that. And then there's ultra, which is a deeper frame, so it's got a slightly deeper glazing unit. We've got a Passive House certified version of this with an insulation core, which we tend to steer people away from. And I think this is answering one of the questions. But generally, although because most of the UK is warmer than our climate zone for Passive House runs into Central Europe, if you like, runs into Germany. So we're all in the cool temperate zone. And to be honest, England and Wales are warmer. So it's not quite as stringent, and we can certainly get to Passive House performance with a solid framed window with the good triple glazing. So this one that Bill's put the cursor over there. But we can always advise you on that, so no problem. This is the ultra in position, again there. And then our final range is our progression range, which is quite a specialist window because it gives you a very particular aesthetic, because the frame is buried in effect, and you'll see in a minute. So the whole of that is covered, and we get this look of just looking in and all you see is glass, whether it's opening or fixed, it looks the same. It's also a very high performance window. It's designed to be a leading edge Passive House window. It's accordingly expensive as well. So this tends to get used here are another of Bill's props. There we are. That's the new version with GRP outside. But you can see that the sash is buried. So when that outside bit is buried in the wall, you can't see the sash. So all you see is glass. And I think the next picture, if you can click it as well, Bill, at the same time. So multitasking boy. This is the kind of look you get. It's very, very clean aesthetic here. And we've used it in a couple of our builds. So the bottom right and the top right are both our constructions. And then there's a lovely, I can't remember who built the left-hand one.
Kirsty McGuire up near Stirling. She's
right.
used external larch reveals with a very sort of traditional rough stone.
Yeah,
quite interesting. Noticed actually the probably aluminium drip that she's got above it here, which is interesting.
You're right, actually. Yeah. But the progression is specified by certain builders and architects who want that aesthetic and want the performance together. But generally, I wouldn't necessarily recommend it just performance. In terms of, unless the budget is fairly generous. I think it's a fairly expensive window to produce, but it is quite unique in what it offers.
But it is beautiful, Chris.
It is beautiful.
It is beautiful. I would have it if I was building my house. I think I would do without the flash kitchen and have these windows personally.
Get rid of the gold-plated taps, would you? Yeah, maybe I would too. Yeah, but I'm just making the point. And again, if you're doing a retrofit, you probably wouldn't choose it. Yeah. Just last point to say, in terms of sales, that we offer more than most window companies do, in that we'll help you with technical. We'll give you technical advice on detailing. If you are building sort of a passive house, or you're modelling passive house even for your retrofit, we've got all the PHPP ready data for all our windows, and some terms and conditions. We will do installation side value calculations as well. Depend a bit on the size of the project, but we will do that as well. So that's all part of our package, and that's us. And we can take some more questions.
Fantastic! Thanks so much. And I've just been trying to keep up with all the questions that have been answered live. So I think we've got a quarter of an hour. Maybe we'll just go 5 minutes over to 25 too, because there's been a few.
Yeah.
But, one thing it would be good just to summarise, Chris, Liam, Bill, are the questions you've answered as we've gone along, because there's been some interesting ones, and I'm not sure everyone can keep track of them all.
Yeah.
So, just really briefly summarise some of the ones that you've answered.
Yeah.
What have we been asked?
Well, I've been answering questions, and
Chris
so
and Liam,
it was just to avoid the boredom of listening to you.
Oh, right. So you've actually been doing it online.
Yeah, I've been sort of typing them in.
Oh, bloody hell.
He's multitasking.
Yeah, bloody Trevor vlogs.
Yeah, and to be honest, I can't remember what I've answered questions about stained glass, which I think is quite complicated, but you can do, depending on what sort of stained glass you want. Liam's been answering as well, so I'm.
There's one about opening outwards, opening inwards.
Yeah, I mean, so Bill was talking about, there is no reason why you shouldn't. There was a question about EWI and why you can't have an outward opening window. Of course you can. It's just that, as Bill was saying, that with an inward opening window, the outer frame is wider, because you think the rebate is on the inside to allow the window to open inwards. Therefore, you've got a wider frame, so you can bring a bit more insulation over the frame. In terms of performance, inward and outward windows will give the same performance, exactly the same performance levels. So choosing whether to go inward or outward is a mixture of aesthetics, what you like, and also if you are neutral about whether you're going inwards or outwards. If you've got EWI, then you can bring a bit more insulation over the frame. It's can be a little bit simpler.
What I didn't say, Chris, was with outward opening windows, one can thicken the frame up if one wants to get even more insulation into the material, into the back of it. Obviously, you then cut out some of the daylight in doing that.
Yeah,
we often have to do that. We're often advised to do that, actually.
Yeah, to get insulation. There is another thing to think about with which helps people think about the detailing, actually, and worth saying, is that if you think about it, if we have an inward opening window with EWI, so we're bringing the insulation over the frame, then we're tending to make the window warmer. We're bringing it to some extent inside the insulation. So it's almost like we're trying to make it warmer. with an outward opening window with internal wall insulation, if we're trying to make the window colder because we're pushing it beyond the insulation. That's not a complete rule, but there's just a little bit of that. So, and if you think about your detailing, so there was a question about sort of whether you could put the window in the masonry, the outer edge of the masonry, and then bring your EWI over the frame. And of course you can do that, but you've still got some thermal bridge there because you've got heat going through the frame and into the masonry. If you can push the window out into the insulation, you minimize that. It may not be practical, but if you can, Bill's shown you some of the ways you can do that. It will perform better.
And there's been quite a few questions around windows and cavity walls. Without going into any too fine a detail, are there some principles there that you could summarize?
Well, I certainly saw one of the questions was around the fact that a lot of cavity walls are actually closed. So the brickwork is brought round and actually butts up to the outer skin. So therefore you haven't got, even if you've got a filled cavity, you've still got a thermal bridge there. But if you've got IWI, then obviously you can bring that through onto the window, onto that reveal, make it warmer. The only problem is always thickness, isn't it? Again, and that's why
we have had situations where people haven't done IWI and they've had their cavity filled and done quite well. We've put in a triple glazed window, but they've still got the thermal bridge of that masonry reveal with the vertical DPC in it. And then suddenly they start getting mold growth where they've never had it before, because suddenly that reveal becomes the Achilles heel of the whole operation. So one has to then have to insulate that masonry reveal.
And that helps if you bring just line that reveal, it will help.
Yeah. Liam, do you want to pick some of the best questions? What I would say is we've had loads of questions and it's been fantastic. We'll try and answer as many as we can. I think we'll also end with a kind of like where now for more information for householders and for contractors. But yeah, if Liam, you just want to answer some of them, or sorry, pose some of them rather.
I'll just pull one out. I've just noticed a very simple question.
Go on then.
Are your windows manufactured in the UK? And our answer is no to that. We used to manufacture, when we started off, we used to manufacture in the UK. To be honest, we couldn't make it competitive in the end. And now our windows are manufactured most of them are manufactured in Lithuania. We've got a very close relationship with the manufacturer there, where we design with them. And the progression windows are manufactured in the Czech Republic. So, and the other, there's also a question, about types of wood, finish, and lifetime, which is it's almost a haiku of a question, I'd say that. So types. I mean, the thing about if a timber window is well made, well fit, factory finished, factory glazed, the sort of thing that we do, and many others do. So I'm not saying it's just us. But if that's the case and it's properly installed, then it should last the lifetime of the building. Really, there's no reason why it should deteriorate. You'll find all timber window guarantees are based on the fact that water doesn't get into the timber, which it won't if it's properly installed. If you install it badly and it's sat in water, a timber window will not survive very well. But then it shouldn't be doing that. You should be installing properly. So you can make windows out of Accoya. I think there was a question about Accoya.
Yes.
And certainly, if a window is badly installed and gets wet, then the Accoya will stop it rotting. But as I say, it shouldn't be badly installed. And we will always advise about installation detailing, or if we're fitting ourselves, we'll make sure it's done right. So your window should last, the life of the building. The technology now in terms of coatings, in terms of adhesives, is such that, with maintenance, a timber window should last almost indefinitely.
And just rounding off that, then there's one from Climate Outreach about PVC rather than wood frame windows. So
you said that would come up.
Yeah,
It's a huge subject, and we can't do it any justice. And to be fair, I can't do it that much justice. I'm not a chemist, but what I know about PVC, well, a couple of things to say really. PVC basically is a quite environmentally damaging plastic. It's one of the worst plastics, because it's chlorinated. So in its production, it results in normally in some emissions of dioxins, which are extremely toxic. chlorine binds to everything. So organic chlorines are very toxic for humanity as well. Dioxins are one of the most poisonous things on the planet. So it's not good news, really. It also takes a lot of energy to produce, so much more energy in the timber window. So it's quite a complex thing. There was a study done by Heriot-Watt University, which we do refer back to quite a lot, showing various forms of timber window, and they all looked at PVC windows and looking at life cycle analysis. And in every measure, PVC windows were far worse than timber. So environmentally, PVC.
And often, and as you've said, timber can last for a long time, and PVC can warp, and need to be chucked away, and
PVC degrades over time. But also, if you get any damage to the PVC window, so if you get somebody break in or something like that, I mean, God forbid, but it happens, doesn't it, pretty regularly, you can't repair them. A timber window, a decent joint, you can usually repair them. So there's lots of reasons. We're firmly in the timber camp.
There's a question at the top here. Look, what training is there to become an installer? Well, we can do training. We do training. There is wider training with the Carbon Light contractor course, for example. And I think you do training, don't you, at Carbon Light? So yeah, come to us and we'll talk you through it.
Okay, maybe now's a good time to pose this. There's lots of quite detailed questions, some of them from householders, some of them from contractors. So if I'm a contractor, want to do more, want to go further with it, what are my options, in terms of working with you, or training or advice, or what?
Once COVID's over, I might add, we can do a lot online, but actually come here to the mill and we'll run through air tightness strategy, fixings, I think that's the best way, face to face, looking at an actual window. Or even going out, as long as you pay me, to see a job and actually advise on installation that way.
But we will also generally look at your installation detail. If you say, if you're ordering from us, we'll have a look at those and say if it's a decent size contract, we'll even do some of the side value calculations for you and throw them in the package.
Sounds good.
We try and give extra support, if you like.
Yeah, and when Carbon Corp in the past, we've done bulk orders, and it's been really responsive in terms of like questions and all that sort of thing.
Yeah.
So Liam, do you want to highlight any questions?
Well, Chris and I had a bit of a back and forth about Kit's question to do with his house and his finger cavity. I didn't quite understand. I didn't quite understand the question, but I thought you did, Chris. So
I'm not sure. I think I don't know if I've understood this correctly, Kit. But this is mainly about fitting into check. So basically, you've got a check is obviously when your inner wall is your opening is a little bit wider than your outer opening, and so your windows are up against the outer skin, if you like. And if that's the case, generally there's no problem with that, and it's pretty much covered by what Bill said about bringing insulation around the inner leaf if you're doing IWI, which might be in that case. So
could I say there, Chris, that if you've got sash windows, you're onto a winner in a way, because you've got that check where the inner opening of the window is wider than the external. So you can bring a lot of insulation round into the reveal, which is where the weights would have been in the past of the box sashes.
That's very true. Yeah.
Any other questions you want to pick out or highlight, Liam?
Yeah. Well, one of them was to do with more air tightness. Would you say it was still worth taping a new double glazed window, which is replacing a single glazed, into a solid masonry wall that doesn't have any insulation? Yes, absolutely, of course. But actually, being pragmatic, if you're replacing, say, in a 1960s, 70s house with smart plaster and finishes into the window, where you pull the window out, you don't want to be usually knocking off the plaster reveal to put on
tapes. I'm being pragmatic now, because you've then got a lot more work in installation, reapplying that plaster work. So there are at least use construction foam spray. I mean, and a lot of our sustainable construction world don't like us using that, but it is bloody good for, excuse me language, for filling up holes. Also, the expanding tapes that I said before, they can be used around the edges of windows against brickwork and masonry as you install. That can be quite neat.
But don't forget, if you are, I mean, we have to assume that most buildings are, or a lot of buildings, an awful lot of our building stock is going to get insulated over the next 30 years, if we've got a chance of addressing climate change. So there will be a program at some point, it's likely in your property. And obviously the window can be taped to later. So it depends where you are really. If there is something to tape to, then possibly it could be good to do it now and it's done. You know, you have to see your building as part of building stock, and as I say, you know, that probably it's going to be upgraded in the next 30 years if the government's going to hit climate change targets.
Yeah, and there's a few questions about green homes grants and what have you, and I think our line's been, you know, we're concerned that the whole house plan element isn't integrated into green homes grant, that it's too kind of single measure or small, you know, limited works. Have you people have asked, you know, is there a tie-in to green homes grants where people can use the grant to get the GBS windows?
Yeah, no, we've looked at this. I'll answer this. The windows are a secondary measure under the Green Homes grant. So the primary measures are insulation or heat pumps. So you've got to have either done some insulation or installed a heat pump before you can do a secondary measure. Now you've only got £5,000. So in effect, by the time you've done that, there is no business for us. And unfortunately, I mean, I follow the, you know, my sins, or sadly, I follow the window trade press quite a lot because I have to, and you know, there is just no interest because there's nothing in it for window suppliers. Just can't, you know, and it's also very onerous to get registered as well. Trust mark. So it just isn't worth it.
Yes, and some very bad publicity.
Every day, we've got people every day asking us about it.
Yeah.
Just
articles today in the Guardian about how angry people are.
Yeah.
Liam, probably just got time for just one more question, I'm afraid.
Yeah, well, this is one which it seems specific, but I think it's actually quite broad, which is we're having our loft converted later this year. Is there any point in investing in good U-value airtight windows for the dormers if the rest of the house is an old leaky bucket?
Yes, absolutely. Yeah. Whatever work you do is worth doing it to how the whole house will become later on. It's a very simple answer.
Going back to that thing, thinking, you know, the housing stock has to be upgraded. We know this. It's, you know, it's actually essential that a very significant chunk of all our housing stock in the UK will need to be upgraded. You know, if we're going to meet climate change targets, that means that there will have to be infrastructure investment in our housing stock. That means that there will be more upgrading. So you've got to assume that your building in the next 30 years will be upgraded, or we have to hope, in fact, that that's going to be able to happen.
And actually, that's going to benefit if you do that attic conversion well, particularly the insulation of your sloping ceilings and air tightness as well. Do it all well. That room's going to be far more comfortable, even though the rest of the house is a leaky bucket.
That's right. Do it properly when you do it, and then, you know, and each part of the house gets done at a different point.
Yeah, and I think that's a nice message to end on, that idea of a whole house plan and bringing things together. So I'd like to say a big thanks to Bill and to Chris. We've been overwhelmed with questions tonight, so maybe if you're up for it, in a few months you could come back again.
Yeah.
Yes.
Clearly loads and loads of interest. So I've just got a few messages before we leave, and one is to plug our service, People Powered Retrofit, which is an end-to-end service for householders who want to retrofit their homes. We work in the Greater Manchester area and a bit beyond as well, and we definitely work with GBS, or we work with people who are commissioning GBS windows and what have you. We've also got a green building store offer if you're a Carbon Co-op member. So there's an email address there, info@carbon.coop, if you want to get involved. In terms of things coming up, We've got a heat pumps webinar coming up on Wednesday, the 24th of Feb with Florence Collier, who's on the call today. It's going to be an introduction to heat pumps, a beginner's guide, and cover some of the ground, like things you need to think about if you're going to be thinking about heat pumps. We've also put out a bit of a call. What do people want to see webinars on? There's been interest in retrofit projects where an architect or a designer comes and talks through the whole process from design to completion, or potentially some contractors as well. Something on insulation types. We also do CPD sessions with professionals and eco-renovation training with Nick Parsons, who's on the call today. We haven't scheduled the next session yet, but it's likely to be in March or April. That's like an entry level. You might be interested in construction or DIY. This gives you a bit of an entry level into retrofit. Tell us what you want to hear if you've got things you want to see. And yeah, as I said before, you can look at all webinars there. Now, hopefully you can see this. We'd really like your feedback on today's webinar. And if you look in the chat, I've dropped in a link to this, what they call a Jamboard here. So really simple. On the left-hand side, good things, on the right-hand side, bad things. And basically drop in post-it notes, which you can do here. Tell us the good things about this session, anything we need to improve, put it in there. Recommendations in the bottom, things you think we should be thinking about. And across the line, 1 to 10, you can mark with a pen here, 1 out of 10, how good was today's session. So all you do, hopefully you can see this, you just click on the sticky note, say, yes, this was good. And then press save, and it appears there on the Jamboard there. There you can see it. Someone's got rid of the good. Put it back. And then, yeah, you can use the pen here to mark out of 10 what you think it was. So the link is in the chat. Just click on that and you should get in, and drop us your comments what you think. Okay, so I want to say again a big thanks to Bill and to Chris, and thanks for your fantastic, your expertise, your experience, your calm, dulcet southwestern tones. very calming within this age of pandemic. So yeah, thanks very much. I'm going to leave the webinar going for 10 or 15 minutes. People can drop in comments, but I'll stop recording now. And yeah, thanks very much.
Thanks very much, Jonathan. Yeah.
Thanks, Jonathan and Liam.
And Liam, yeah.
Lovely to see you.
Yeah, you too.
Thanks.
Always a pleasure.
And you. Bye.
Bye.